In this video, we will learn how to expand a binomial raised to a power, such as this. To do it, we're going to use something called Pascal's triangle, which follows this pattern. You start off with 3 ones, and then you're going to add 1 plus 1 is 2, and then you finish off the row with ones. 1 plus 2 is 3, 2 plus 1 is 3, finish off the row with ones. 1 plus 3 is 4, these two make 6, that's another 4, finish off the row with ones. What the heck, one more row. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and you finish off the row with ones. Now, these rows form the coefficients of polynomials. So if I want to do a binomial raised to a power, if that power is the 0 power, I use this row. If I want to do the first power, then I use this row. If I want to do the second power or the third power or the fourth power or the fifth power, I'll just need to know which row we are talking about. So for this particular problem, we're supposed to expand 3x plus 2 to the third power. That means I will be using this row 1, 3, 3, 1. So those will be my coefficients. So I'm going to start by writing those numbers down. So I have 1, 3, 3, 1. Now they always start off positive, so I'm just going to put a little plus sign in front of each one of these. Now, I'm going to start with this term, 3x. And I'm going to put it on the left, 3x. Now I'm going to start with the power that we have, so 3x to the third power. And then I will decrease the exponent as I go to the right. So this will be next 3x squared, and then 3x to the 1 power, and then 3x to the 0 power, so I don't put anything down at all. Next I will do the term positive 2. This time I will start from the right at 2 to the third power, because that's the power of the problem. And then I will have 2 squared. And then I will just have 2 with no power. And then 2 to the 0 power, so you don't put anything at all. So that's step 1 is the setup. Maybe I'll label these over here to the left. So step 1 is the setup. Step 2, I'm going to do the powers. And step 3, I am going to multiply. Alright, set up, do the powers, multiply. Those are the 3 steps of this problem. So it's time to do the powers. So everything that has an exponent on it, I'm going to do something to it. Now, for starters, the coefficients don't have any powers. So I'm just going to bring them down unchanged. So I've got 1, I've got 3, the 3, and the 1. Those aren't changing. They have no powers. Now, look at the pink part. So I've got 3x to the third power. I have to do 3 to the third power and x to the third power. 3 to the third power is 27. So I've got 27x to the third power. 3x squared, that's 3 squared and x squared. 3 squared is 9. And of course, x squared is just x squared. This 3x doesn't have any power, so it doesn't change. Okay, now look at the green part. 2 to the third power is 8. 2 squared is 4. This one doesn't have any powers. So now I've done all the powers in the problem. Okay, all these powers that were outside of the parentheses. Now there's still some exponents, but they're inside the parentheses. They're on these variables now. Now it's time to multiply. And this is the last step, right? This is going to be the final answer. 1 times 27 is just 27. So I have 27x to the third power. Now here I've got three numbers. I've got 3 times 9 times 2. Okay, let's see. I'll just tuck this over here. So 3 times 9 times 2. That's 54. And then I've got this x squared I see. Now 3 times 3 times 4, that's 9 times 4, so that's 36. So 36x. And then 1 times 8 is just 8. So this would be your answer to problem number 1. Okay, now let's keep going and do problem number 2, since it is following the same pattern. Let's start by the coefficients. So I have the fourth power. Alright, that means we're going to do 1, 4, 6, 4, 1. Okay, so let's write that down. So we will do 1, 4, 6, 4, 1. Okay, remember that they always start off positive. So, first I'm going to start with this x. So over here I've got x to the fourth power. Because it's just x and not 2x or 3x or 4x, I don't need parentheses around it. Okay, like if it was like 2x, I would have to have parentheses, so I would remember to do 2 to the fourth power and x to the fourth power, and I would get 16x to the fourth power. But if I just have x, then it's just going to be x to the fourth power, so no need for parentheses on that. So I'll have x to the fourth power, and then x to the third power, and then x squared, and then x, and then nothing. On the right hand side I've got this negative 3. Now if this was just a 3, I wouldn't need parentheses for that either. But because it is negative 3, I'm going to have parentheses to wrap up that negative sign. So I will have negative 3 to the fourth power, negative 3 to the third power, negative 3 squared, and just negative 3. So that's the setup step. Now it's time to do the powers. Okay, the 1 and the 4 and the 6 and the 4 and the 1 do not get involved in the powers. They don't have any powers. In this case, even the x to the fourth power, the x to the third power, x squared, and x, even though these have powers, they are already simplified. You can't, x to the fourth power, there's nothing else you can do with that. Okay, so that just leaves the green part. Negative 3 doesn't have any powers on it. Negative 3 squared is positive 9. Okay, notice, if you're going to use your calculator, which I hope you don't need to, if I use parentheses I get positive 9. Be careful not to do negative 3 squared like that, because it might have you believing that it is negative 9, which is false. So put that negative 3 in parentheses, and you'll get positive 9. Similarly, I have negative 3 to the third power. Now this is going to be negative 27. Alright, if you have an odd power, negative things stay negative. So this is going to be negative 27. Negative 3 to the fourth power turns out to be positive 81. So notice the ones that have an even power, like 2 and 4, turn positive. But the ones that have an odd power, like 3 or even 1, stay negative. Okay, so now we've done the powers. Now it's time to multiply. Well, 1x to the fourth power is really just x to the fourth power. Here I have 4 times negative 3. That is negative 12. So negative 12x to the third. 6 times 9 is 54. So we'll have positive 54x squared. 4 times negative 27, I'm not really sure off the top of my head, so 4 times negative 27. That's negative 108 x. And 1 times 81 is just 81. So this would be your answer to number 2.